Welcome to Concept Based. I'm John Hepworth. This one's for Year 11 Advanced students. We're in the Working with Functions section, still doing algebraic techniques. Now, I did mention that I'd be skipping a few dot points in the algebraic techniques this year. And one of those dot points I'm going to go past is the solving quadratic equations. I think you've done this a million times in stage 5. We even looked at a little bit of it earlier this year, and we just don't need to go down the path of all of the different types of solutions that you have to do. However, one of the types of solutions that you did in stage 5 and again in stage 6 now that comes up is using the quadratic equation. And there's a part of the quadratic equation that we want to explore. So you've been using this, and hopefully you can just write this out. You don't need to look at your formula sheet. You just remember it from the lots of times you did it in stage 5. Not because I just want students to remember everything, but the main advantage of just remembering equations that you use regularly is time saving. If you find yourself in the HSC exam in a couple of years and you're having to look up all of the formulas still, then that's just going to cost you more time. And any time that you're doing that, you're not solving problems, and we want you to have as much opportunity to solve as many problems in the HSC as you can. So this is the quadratic formula, and it gets us magical solutions from any quadratic that we put into it. However, we have noticed that sometimes it doesn't give us solutions, and we notice that that happens when this part of it here is negative. You may have also noticed that when you have this part here equaling 0, you only get one solution out of the quadratic equation. So this relates to the dot point in your algebraic techniques to find the discriminant. So this is referred to as the discriminant, and the discriminant will tell us information about whether the roots are real, imaginary, whether they're equal, whether we can find them or not. And the reason why it does this is because if this section is negative and it has a square root around it, then we can't do the square root of a negative, so we can't get any solutions. If this part is equal to 0, then it just disappears, and we now don't have this plus minus thing in our equation, so we don't end up with the two solutions. We just end up with negative b over 2a. But if it's positive, then we do get these two plus or minus parts of the solution, and we get two zeros, two roots of the quadratic equation. So what I'm doing today is I'm asking a question that sort of flips it. It makes it a little bit more conceptual because the questions that you get asked in the HSC aren't all straightforward. You can't just plug them all into a formula and away you go. So let's have a look at the question I've asked. Show that a parabola with a double root has a discriminant of 0. So you have to understand what that terminology means. First of all, that it has a double root, or it might say or equal roots. And then we know that it has just the parabola. If I was going to sketch it, which I love for my students to sketch things, what it means is that it's just touching the x-axis once. We use the word double, even though it only has one solution, but we do use the term double in terms of the multiplicity of that root, in terms of this bouncing off the x-axis here, only at a single point. Now, we don't know where this root is. This question doesn't give us this information, so we're just going to define that root as being at alpha when we go ahead and do this proof. So we want to try and prove or show that a parabola with this double root, where it has a 0 only at one place, has a discriminant of 0. Now, first and foremost, we should expect this. We should understand that this is definitely going to be true based on what I just said off all of the calculations you've done in year 10. In that part of the formula where we have b squared minus 4ac, which is the discriminant part, if that equaled 0, we didn't have the plus or minus, so we only had one root. So this is what we expect. This is what we just looked at. Okay, so being that it's just what we expect, how can we prove it? So what we could do is we could say that this parabola is expressed as a factor of its linear, as an expression of its linear factors, where it has this double root, or the root occurs once only at a certain point. And we're going to call that point alpha. Alpha 0, you could say, is where it hits the x-axis. So With this now, we're going to go ahead and expand this and get y equals x squared minus 2 alpha x plus alpha squared. And so now that we've expanded it, we get it into a form that sort of fits with our quadratic formula and also therefore our discriminant. So we've got this idea that our discriminant is b squared minus 4ac, and that's what we're going to go and substitute in. So let's do that. So if we substitute that in, be careful with the b. So the b term is talking about the number in front of the x in the middle, and it always comes with the sign. Now, coming with a sign doesn't matter because if we square it, a negative is going to be positive anyway. But we are going to write that down because we are showing, so let's make sure we get this all accurate, minus 4 times a, so the a out front of the x squared is a 1, times c. And the c, we've got this alpha squared thing, which we introduced as the root. So now if we expand this further, we get 4 alpha squared minus, and then over on this side, negative 4 times 1, negative 4, and then alpha squared minus 4 alpha squared. And then negative 4 alpha squared minus 4 alpha squared is 0. Ta-da! Like some sort of magical trick that at the end this 0 just pops out. But it is what we expect. So this type of question is that type of question that sort of delves a little bit more into concepts, a little bit away from procedures, because you have to understand, first of all, the terminology, this double root and this discriminant. But then you have to understand how to express the quadratic yourself, and then expand it, and then relate it back to this procedural b squared minus 4ac that we're doing, and have the result equals 0. So the discriminant, very powerful. It's going to tell us a lot about our graphs. It's going to give us information immediately when we are trying to sketch things, if we want to use our sketches to help identify where we're solving things, whether it has 2 roots, whether it has no roots, whether it just has the double root at the one place, like the one in this question. So we want to use that. Now, I probably will go into a little more of a trickier question in relation to this in the future, but if it's something that you want to think about right now, what if we had a parabola and then we had a line that went through the origin and was a tangent to the parabola where the gradient of this line is positive? Oh, that's a little bit far off. Where the gradient of this line is positive. What would you be looking for there when you're trying to find something as a tangent to a parabola? Something to think about, maybe a question that I'll do in the future. Again, if you're looking for some tutoring about these types of concepts, please email me info@concept-base.com.au.